Hi everyone. So today we are going to see the second lecture of control systems, that is conversion of block diagram to signal flow graph, and this is Penila. So to convert the block diagram to signal flow graph, you have certain procedure to follow. So step 1 is to represent this input signal R of S and output signal C of S of a block diagram as an input node R of S and output node C of S of a signal flow graph. You can mention it as R and C also. Step 2 is to mark the branch point and summing point as node starting from input towards your output. Step 3 is to draw the signal flow graph as per the direction given in the block diagram. So mentioned in the block diagram, we have to follow the direction of the arrow mark. So we'll solve one problem here. Here I will show how to convert the block diagram into a signal flow graph and determine the transfer function of t using the Mason Gaines formula. Already I have posted the lecture 1. You can get the help from the lecture 1 here. So here this is the block diagram we have given. For this block diagram we have to find the signal flow graph. So as it mentioned earlier, so we have to take this R of S and C of S is going to be a node here. So I'll start from this R of S as an input node. So this is going to be 1. This is going to be your branch point. So I'll be naming it as a 2, and this is going to be your summing point. So it's going to be 3, and then it's going to be another summing point. So it's going to be 4, and then this is going to be your branch point. So it's going to be 5, and then this is going to be another branch point. It's going to be your 6, and then this is going to be your summing point. The value is going to be 7, and then your C of S, that is going to be your output. So it's going to be your 8 here, right? So now I'm just mentioning all the nodes. First 1, 2, 3, 4, 5, 6, 7 and 8. Now from this 1 to 2, right? So this is going to be 1 is going to be your R of S, and then your 8 is going to be your C of S, right? So I'm just going to act as a R and C. So this 1 to 2, there is nothing is there, so the value of gain should be 1. In between 2 and 3, there is no gain, so the value is 1. And from 3 to 4, the gain is going to be G1. And then 4 to 5, the gain is going to be G2. And then 5 to 6, the gain is going to be G3. And 6 to 7, it's going to be 1. And 7 to 8, it's going to be 1. Again, so from 5 to 4, you have a feedback with your H1. Again, this is to be your 3. So your 5 to 3, the value is going to be same H1. Then it's going to be 6 to 4. The value is going to be H2. And then from 2 to 7, it's going to be your G4. So now this block diagram is successfully converted into the signal flow graph. For this signal flow graph, we have to find a transfer function using your Mason's gain formula. So this is already available. I have given the video here. I have given the URL of the video in the description box also. And this is going to be the YouTube. You can watch the YouTube to convert to find the transfer function of a signal using your Mason's formula here, right? So the practice problem is the block diagram of the system shown below. Determine the transfer function using the Mason's gain formula. Mason's gain formula tells you that the block diagram should be converted to a signal flow graph, and then we have to find the transfer function using the formula 1 by del into summation k, pk into del k. Thank you guys. Have a nice day. Subscribe my channel for automatic updates.